everyone, and welcome to this explainer. Today, we're going to do something a little different. I want to invite you to slow down for just a few minutes and take a closer look at something you interact with literally every single day. We're going to explore the unseen, completely fascinating chemistry of the tap water you drink, wash your clothes with, and, let's be honest, probably take for granted. So get comfortable, take a deep breath, and let's explore the everyday magic flowing right out of your faucet.
So if you're hanging out at your dorm room desk right now, or maybe taking a study break in the library, I want you to pause and mindfully consider a simple glass of water. Just really look at it. It seems perfectly basic, right? It's transparent, tasteless, completely ordinary. But beneath that still surface is this rich, dynamic history of chemical interactions and incredible engineering that goes entirely unnoticed in our super busy college lives.
Okay, let's dive right into this. I mean, we all know water covers almost 75% of the Earth's surface, making it nature's most abundant compound. But the reality is that those beautiful, pristine droplets represent a very rare and precious commodity. It's absolutely essential for all living things, yet the journey it takes to get to us, it's highly, highly complex. Section 1. The miracle in your glass. Before we get into how water actually gets to your tap, we kind of need to reframe how we even think about it. We so often treat water as just a boring, everyday liquid, but scientifically speaking, it's an absolute miracle. It's a true earthly anomaly. Our engineering chemistry sources highlight this really beautiful fact. Water is literally the only known substance that can naturally exist as a gas, a liquid, and a solid within the relatively small range of air temperatures and pressures found right here on the Earth's surface. It just shifts seamlessly between ice, flowing liquid, and invisible vapor. It is incredibly unique. Section 2. The universal solvent. Now, because of this unique chemical nature, water rarely travels alone. Let's shift our focus to the journey water takes across the Earth and how it interacts with the world long before it ever reaches your dorm building's plumbing. Water is famously known in chemistry as the universal solvent. Because of its molecular structure, a vast array of substances easily dissolve right into it. As a single drop of water travels miles over rocks and percolates down through layers of soil, it inevitably picks up invisible hitchhikers. It dissolves minerals like calcium, magnesium, potassium, and sodium. What this means is that perfectly pure water is actually incredibly rare in nature. And this brilliantly illustrates the crazy duality of water. We have the visible, pristine-looking drops we interact with every day, but beneath that is a bustling microscopic reality. Those water molecules are actually holding complex dissolved minerals in solution. And these minerals can't just be removed by simple physical processes, like basic filtering or letting the water sit still in a jug. They are chemically bound into the water itself. Section 3. The hard water problem. All right, let's connect all this unseen chemistry directly to your everyday life. Have you ever noticed that doing laundry in your dorm feels, less effective? Or that your morning shower leaves your skin feeling a bit different than it does back in your hometown? Yep, that is the universal solvent at work. When water hasn't picked up many minerals, like rainwater for example, it's called soft water. It forms a really rich, creamy lather with soap. But municipal systems often rely on groundwater or river water that has picked up a whole lot of calcium and magnesium along its journey. We call this hard water. And hard water just doesn't lather well. Instead, it leaves behind this sticky, curd-like residue. So if you've been totally frustrated by your soap refusing to lather in the dorm showers, take a deep breath. You aren't doing anything wrong, and no, it isn't some university conspiracy to buy cheap soap. It is purely a chemical reaction. You see, soap is essentially a sodium salt of a fatty acid. When those dissolved calcium and magnesium ions in hard water meet your soap, they react with those fatty acids. Instead of creating nice fluffy bubbles, they precipitate out as that sticky white curd. It's really just the natural minerals in the water expressing themselves. Section 4. Making water potable. So if natural water is absolutely full of minerals, debris, and microorganisms from its journey, how on earth does it become the safe, clear liquid we drink every day? Well, this brings us to the invisible municipal engineering that protects us, a continuous, unseen active care happening around the clock. The ultimate end goal of this massive treatment process is creating what we call potable water. This simply means drinking water that is safe enough to be consumed by humans with a low risk of immediate or long-term harm. And getting water from a murky river to a potable state, that requires some seriously strict engineering standards.
So the absolutely crucial point here is that your tap water is highly, highly regulated. Before it ever reaches you, it must meet several specific characteristics. It has to be sparkling clear, colorless, and completely odorless. It needs to be pleasant to the taste and perfectly cool. Its alkalinity is carefully balanced to maintain a pH generally between 7.0 and 8.5. And most importantly, for sure, it must be entirely free from disease-producing biological impurities like bacteria and viruses. To put that into perspective and give you an idea of how strict these standards really are, consider this number, 10 ppm, or parts per million. That is the maximum allowable limit for turbidity, which is basically just the cloudiness of the water. If there are more than 10 parts of suspended solids in a million parts of water, it flat out fails the test. The precision involved in treating your water is genuinely remarkable. Now, to achieve this incredible level of safety, water goes through a multi-step journey. First, it undergoes screening, where large floating debris, we're talking leaves and twigs, are simply blocked from passing through. Then comes sedimentation, where the water is allowed to sit perfectly still in massive tanks so gravity can pull the smaller suspended particles right down to the bottom. Finally, it undergoes disinfection, usually through chlorination, where carefully measured amounts of chlorine are added to completely destroy any harmful microorganisms. Now, what's really interesting is how we handle water that is incredibly stubborn, like seawater or highly brackish water. For that, advanced techniques like reverse osmosis are used. It's like a giant microscopic puzzle. In this process, water is forced under high pressure through a semi-permeable membrane. This membrane is so unimaginably fine that it allows the water molecules to pass, but traps those tiny dissolved ionic minerals and microscopic suspended particles, like colloidal silica, which are essentially just ultra-fine particles of sand and minerals. The result? Highly purified water. Section 5. A peaceful takeaway. As we wrap up this explainer, I want to bring us right back to that glass of water sitting on your desk. Understanding the chemistry behind it doesn't just help you pass an engineering exam. It can actually give you a moment of grounding in a super stressful day. Our sources perfectly summarize this whole process with this thought. As water flows over the surface of Earth, it picks up several impurities. Some make water more useful, and some render it unfit. The quality of the water in your glass is really simply a reflection of the incredible, dynamic journey it took across the Earth's surface just to reach you. So the next time you take a sip, or honestly, the next time your soap doesn't quite lather the way you want it to, I hope you'll take a breath and smile. Think about the minerals it carried from miles away and the massive, unseen engineering effort that made it safe for you to drink. What unseen journey did your tap water take today? Take a little moment to appreciate it. Thanks so much for joining me on this explainer, and stay curious.